Assalamu alaikum all. Can you hear my voice? Yes, can you hear me? Okay. So we have started broadband network management, which includes wired and optical access network. That is chapter number 13 in our face-to-face lecture. And we have discussed that there are three emerging technologies. The first one is hybrid fiber coaxial cable, that is HFC, which is also known as cable modem technology. The second one is the digital subscriber line, that is DSL, and wireless technology, and it is also called optical fiber technology. So of the three, we have HFC and ADSL that are the ones that are in a more mature state of implementation. So when we have discussed them one by one, we have seen that HFC basically carries information from the head end to the customer premises by using optical fiber and coaxial cable. That's why its name is hybrid fiber coaxial cable network. And there are cable modems at the customer site and a cable modem termination system. So transmission is two-way in most of the implementations. Now the second one is DSL technology. And in DSL, we have three different types of DSLs. We have first one, that is ADSL, and this is most widely implemented configuration of DSL. Now the next two is HDSL and VDSL, and they can handle greater bandwidth and capacity of information. So we will see them one by one. So the first one is the ADSL network. So among all XDSLs, basically ADSL, that is asymmetric digital subscriber line, is the technology that is used in almost entire world, and a simplified access network which uses ADSL is shown in this figure, where we have a broadband network. As you can see over here, we have ATUC, and next we have a splitter, then we have ADSL loop, then again we have a splitter, and then ATUR. So it consists of an ADSL transmission unit, that is ATU, and the splitter at each end of ADSL line. We have ATU at the central office, and that is called ATUC, and another one is at the customer premises, or we can say at the residence of customers, so that is called ATUR. That means transmission unit at remote or residence. Now the data and the video signal from the broadband network is converted to analog signal by ATUC, and it is multiplexed and demultiplexed. Now the splitter over here at the central office combines plain old telephone service that we call POT, P-O-T-S, POTS. So this is a voice signal and the broadband signal. And the reverse process occurs at the splitter and ATUR at the customer premises. So there are modems which are available and that embed the splitter, and it eliminates a separate splitter at the customer side. So that's why this type of configuration is also known as ADSL Lite, L-I-T-E Lite, or we can also say G Lite. Now here we have ADSL spectrum allocation with guard band. So the POT signal is always allocated. The baseband of 4 kHz, and they are separated from the broadband signal by a guard band. So there are two schemes for separating the upstream and downstream frequency band, and that we call as frequency division multiplexing, that is FDM. So in FDM, actually, after separating the upstream and downstream bands, each band is divided into one or more high-speed channels and one or more low-speed channels. So in echo cancellation, upstream and downstream bands, they both of them overlap, but they are separated by a technique that we call as echo cancellation. So using echo cancellation, the low frequency end of the spectrum is made available for downstream, and therefore it increases the overall downstream spectrum band. So within the upstream and downstream bands, the individual channels are allocated a multiple of 4 kHz band using either standard discrete multitone, that is DMT, or carrierless amplitude phase, that is CAP modulation. So the modulation scheme is more efficient, but it is complex and it is costly also. But still they are used currently. So standards, they are addressed by various standards organization of XDSL. So when we discuss about different types of customers, we can see that not all residential customers could have the privilege of getting ADSL service. Only those who have direct copper connection from the central office could be served with ADSL. So telephone loop facilities with loaded coils do not qualify for the service. Now besides, many newer residential complexes have fiber optic cable to the neighborhood and twisted pair from FTTN to the residence. So for these residences, telephone companies offer VDSL, that is very high data rate digital subscriber lines. Here we have the selected documentation from DSL or broadband forum. Now here we have VDSL network, and this network has the benefit of providing greater bandwidth. So the signal basically traverses the optical fiber medium from the central office to the optical network unit that we call as ONU in the neighborhood, which carries multiple channels, and it is demultiplexed at ONU, and it is fed through VDSL modems and twisted pair cable to the residence. So here we have a bandwidth of 55.2 megabits per second downstream and 2.3 megabits per second upstream. So much of the latest documentation on ADSL is available on TRs, which are published by ADSL forums. So we have RFCs that are, yes, Hala. The difference between VDSL and ADSL is that VDSL provides you greater benefit of bandwidth. That is, the bandwidth is high in case of VDSL as compared to ADSL. So here the data rate that is provided is as I've told you, for the upstream and the downstream data is 55.2 Mbps and 2.3 Mbps for downstream and upstream respectively. Yes, Hala, is it clear? Yes. So here we have ADSL forum, which is available in the public domain of broadband forum web page, and some TRs that are relevant to the basics and management of DSL. So we have broadband forum view of how ADSL basically access the network and how it fits into the overall network for the broadband services. So here we can see the components of overall network comprising of private, public and premises network, and the role that ADSL access network plays in it. So the networking side of the service providers consists of service systems and different types of networks that are behind the access node, the operation systems, that is OS, and that perform the operations, administration and maintenance tasks that we call as OAM, that is operation, administration and maintenance. So this is done for the network and access node. And we can also see here ATUC. So basically the customer premises have network premises, that is ATUR, and premises distribution network that we call as PDN, and various service modules like SM, as you can see in this figure, and the terminal equipment in the end, that is TE. Now at the bottom of this figure you can see 5 transport modes that shows you the process from a primitive synchronous transfer mode to ATM mode. So the service systems are on a private network which provides online services, internet access, LAN access, and interactive video and video conference services. So the private network interfaces with the public network, which is the broadband, narrowband or packet network, and the access node is the concentration point for the broadband, narrowband data and the packet data. So it is either located in the central office or in a remote location such as ONU. And the access node includes ATUC, such as in digital subscriber loop, access multiplexers. So basically the access network at the access node extends up to PDN in the customer premises. Now this figure shows you ADSL system reference model. Here we have additional components that we call splitters at the central office and the customer premises, which separate low frequency telephony from voice, video and digital data. We have a public switch telephone network that we call as PSTN, and it is the switch that is connected at the central office, and the telephones are of the splitters at the customer end. So we can see that the digital broadcast and the network management interfacing with the access node, and digital broadcast is the broadcast video, and network management could be treated as one of the operations system components. So the system reference model here have the interfaces between components of ADSL network and interfaces between ADSL access network and external network. So there are basically 5 basic interfaces. We have V, U, G, B, and we have POS. Now here you can see we have these interfaces between the access node and the network, and it is usually a physical interface. So interface is basically can have multiple physical connections. So V interface have VC interface between access node and the external network and interfaces. We have U interface, that is optical splitters. We have POS interfaces, that is low pass filter interfaces. And T and B are the customer premises network interfaces. T is between CDN and service module, and B is the auxiliary data input, for example, satellite feed. So these U interfaces may disappear when we have ADSL live and it is implemented. So it is highly unlikely for a long time, and port interfaces are also from the splitters. And we have B interfaces, that is a satellite feed directly into an SM, such as a set-top box. Here we have ADSL channeling schemes. So there are basically 2 perspectives in discussing the transport channels in an ADSL access network. The first perspective is that we have traditional transport bearer channels as they are defined in ISDN, that is Integrated Services Digital Network. So for ADSL transport frames, there are basically 7 AS bearer channels which are defined for the downstream signal operating in a simplex mode. We have AS bearer channels. They are in multiples, for example 1, 2, 3 or 4 of T1 rate of 1.536 megabits per second or E1 rate of 2.048 megabits per second. So in addition to downstream AS channel, there could be 3 additional LS duplex channels which carries the signal in both downstream and upstream direction. We have LS bearer channel, that is 160, 384 or 576 kilobits per second. And the second perspective in discussing the channels is how the signal is buffered while traversing ADSL link. And this is what you can see in this figure. So we have real-time signals such as audio and real-time video use a fast buffering scheme, and therefore it is referred to as fast channel. And the digital data that could tolerate delay use slow buffers that are interleaved between the fast signals. The digital data channel is known as interleaved channel, and a physical interface will carry both fast channel and interleaved channel, and it has to be addressed in the network management of interfaces. This shows management response model, and this is the general framework for ADSL management. So it has a number of additional components that identify the switching and the physical layer functions explicitly, and the management functions which are addressed in ADSL specific documents. They deal with the physical layer functions, and the management of data layers is addressed by the conventional NMS, that is network management systems. We have low pass and high pass filters that are explicitly shown in this figure. So ADSL network management deals with parameters, it deals with operations and the protocols, and these are associated with the configuration, fault and performance management. So security and accounting management are not explicitly dealt with, although these are important management functions and are addressed by other models. So the management of ADSL network involves basically 5 network elements. We have management communication protocol across the network management subinterface of V interface. The second is the management communication protocol, which is across U interface, and this is between ATUC and ATUR. The third one, as you can see over here, we have parameters and operations with ATUC. Fourthly, we have parameters and operations within ATUR. And finally, we have ATUR side of the interface. So all these management functions in ADSL network, they are accomplished by using V interface. So the management function at the physical layer, it involves 3 entities: physical channel, fast channel, and interleaved channel. So fast and interleaved channels, they need to be managed separately, and these use the physical transmission medium, and they also need to be managed. So beside the management of physical links and the channel parameters, the parameters associated with the type of line coding needs to be monitored. So next we have signal power and data rate management. Here we have 5 levels of noise margin, and the signal power is controlled by noise margin. The data rate increases or decreases based on the threshold margin. So we set a threshold value for that, and whenever that threshold value is exceeded or whenever it is below the lowest level, then it increases and decreases the data rate. And the data rate adaptation modes include manual, automatic, and dynamic. These are the configuration management parameters. So here we have various parameters that are to be managed for configuration, and this table lists the components that the parameter is associated with, as well as it includes the physical line or fast or interleaved channel, and the description is also given accordingly. So here we can see that the link can be configured in one of the 5 options, and here we have fault management parameters, and they are displayed by NMS, that is Network Management System. So after automatic indication of fault, what happened? ATUC and APUR, they perform self-test, and this is done to assist in the diagnostic operation. This table shows the performance management. Here each ATU performance is measured in terms of line attenuation, in terms of noise margin, total output power, current and previous data rate, along with maximum attainable rate, channel data, block length, and interleave delay can be monitored. So there are both SNMP and CMIP based specifications that have been developed for ADSL. So here you can see there are 3 nodes that are defined under ADSL line MIB. So basically RF specifies ADSL MIB objects, and there are complementary objects for the link in terms of physical and channel objects. Now ADSL is further classified into ADSL2 and ADSL2+, where we have rate and reach improvements. ADSL2 basically adds new features and functionalities to improve the performance and interoperability. And improvements include higher data rate, longer reach, rate adaptation, diagnostics, and part saving standby mode. So the data rate increase in achieved by improving the modulation and coding efficiencies. We have a downstream data rate of 12 megabits per second and upstream data rate of 1 megabits per second that can be achieved. Now in case of ADSL2, modulation and framing layers are decoupled, which enables the transmission data rate to be changed without affecting the framing layers, and therefore the data rate is changed based on the extent of external disturbing effects of crosstalk and other parameters such as radio, temperature, and water, etc. And power saving is accomplished by ADSL modems, which operates at 3 levels. Very low power sleep mode when there is no data transmission. Then we have medium power mode when the internet traffic in the access network is normal, and high power mode when the traffic is heavy, such as when we transfer large files. Now in case of ADSL, now in case of ADSL2+, the specifications basically double the downstream data rate to 2.2 megabits per second. And as VDSL does not completely satisfy the need of triple play service, the Broadband Forum has created VDSL 2+, which is a complex protocol, and it incorporates the features and characteristics of both ADSL, ADSL 2+, and VDSL. So basically, the performance improvement in DSL is achieved by the use of multi-channel transmission. And finally, we have passive optical network. This is the third wired broadband access network, and it is not really wired, but the copper is replaced with fiber. So PON can also be implemented on copper. So optical access networks basically use optical fiber transmission from the central office to the customer premises. And the transmission path could have active elements such as regenerative repeaters or amplifiers. So passive elements such as a beam splitter or a wavelength division multiplexer, that is WDM, could be present in passive optical networks. Okay, this figure shows the generic PON architecture. It is the segment between the optical line termination, that is OLT, that is located in the central office, that is CO, and the ONU equipment, that is located in the customer premises, that is CPE, or we can say at home. Here we have PON configurations, and this shows PON configuration point-to-point PON, where fiber is run from an OLT to either ONU. So in this case, ONU performs a similar function to the NIU as in the cable access network. This figure shows PON configuration, that is EPON. Here we have ONU, which is a passive optical power splitter combiner, which distributes the signal to multiple homes. So the link between OLT and the passive optical splitter combiner in this case uses Ethernet or ATM protocol. And because it is Ethernet PON, that's why we also called it as EPON. So here the optical signal between ONU and OLT is in two directions, and it could be carried on two different wavelengths or on a pair of fibers. The next figure shows you PON configuration, which is called WPON. Here in this configuration, we have individual homes that are served over different wavelengths. So we have WDM, which is the ONU, and it performs the function of multiplexing and demultiplexing the signals from and to the home. So different modes of transmission distributions are used in PON. As you have seen, there are three different ways. So APON is ATM based, EPON is Ethernet based, and PON GPON is a hybrid that uses EPON and APON systems. The EPON network is also known as EFM, that is Ethernet in the first mile. And we have WDM PON, which is referred to as WPON. This is the EPON protocol architecture. This is EPON MIB, EPON group, so here we have seen that EPON belongs to the first class that uses traditional TDM, downstream broadcast mode, and TDMA, upstream mode of transmission. And the MIB that is developed is by IETF, that is Internet Engineering Task Force. And the second class basically splits the energy from the head end over multiple wavelengths. So this is all about this chapter, which includes broadband network management, and this is wired and optical access network. Now inshallah, in our next face-to-face lecture, we will discuss about broadband network management, but that will be wireless instead of wired. So that's all for today. If you have any question, you can ask. We still have time. If you need to ask anything, you can ask. Otherwise, we will meet in next face-to-face lecture. Okay, thank you all of you. Assalamu alaikum.